Okay, so today we're going to go over how to simplify a radical expression by rationalizing the denominator. Okay, so there's our question. We want to simplify that radical. What is the simplest form of the cube root of 5x squared divided by 12y squared z? Sounds like a mouthful. Okay, so the first thing that we're going to want to do is, now we have the rule in math that says if I have two radicals under two square roots, I can turn them into one big radical. I can also reverse that process. So when I start with one fraction under one square root, I can divide it into two fractions under two square roots. So I make one radical in my numerator and one radical in my denominator.
You have to do that?
Yes. Because if you could divide those, then you wouldn't have to go through this whole process. But since you can't divide 5 by 12, we have to find a different way to simplify the problem. And that's by rationalizing the denominator. Yes? No, that's part, when you type up characters, every time that you do a superscript, if you go to underline, it's annoying. It doesn't underline where it underlines the 5 and the x. It underlines at the superscript. But what I learned was, don't do this. If I have something like this, I draw it by hand in class. But again, 3 years ago, I didn't realize that. No, that's exactly what Matt just asked me. No, it's not a negative sign. It's part of the underline here. You can ignore that. All right. So the first thing we do is separate. The second thing we do is factor the radicand. In other words, the stuff that's inside the radical sign. What you want are prime, with your numbers, you want prime factors. Okay, you're going to do a prime factorization of any number in the denominator. So you can see on the board, I did a prime factor tree of 12. You're, of course, not obligated to do a prime factor tree, but as you can see, it is a handy tool and it will be helpful. So I break down 12 into its prime factors, which is 2 to the second power times 3. I leave my exponents alone.
Is this for the bottom?
Only for the bottom. You don't do anything to the top yet.
Oh.
That's why it says denominator here, because that's all we're doing. We're just doing the denominator. Okay, now, there's a reason that I'm doing that. What does it mean? I just explained, and who can remember, what it means to rationalize the denominator. Bless you. If you think about the term rationalize, if I have the square root of 12, the square root of 12, or in this place the cube root of 12 is an irrational number. It's 2 point something. But it's a decimal that goes on forever. You cannot find the exact value of the square root of 12. So if we had some problem, some mathematical equation where we needed to know the square root of cube root of 12, simply plugging it into our calculator isn't going to help us. So instead what we're going to do is we're going to find some number to multiply it by so that we end up without the the square root of 12 so that we just end up with 12. 12 is a rational number. You can divide by 12. You can't divide by the square root of 12 or the cube root. So that's what the concept of rationalizing the denominator means. The way we accomplish that is we're going to multiply. Let's make this blank now. We're going to multiply the denominator by whatever helps us get groups of 3. Because we're dealing with the cube root, what we want in the denominator are groups of 3. What I mean by that is, I have how many 2's here? 2 to the second power is how many 2's? Not the answer. How many 2's is it? 2. How many 2's do I have to add to that to make 3? 1. So I'm going to multiply this by 2. And I'm going to do that for each thing in my denominator. So if I have how many 3's here? 1. How many 3's do I need to make 3? No. I have 1. Stop looking at the value and look at the numbers of the quantity. I need 2 of them. So I'm going to multiply it by 3 to the second power. I don't want the value of 3. I want groups of 3. So I have 1 3. I need 3 3's. How many 3's do I need? I need 2. I have 2 y's. How many y's do I need to make 3? 1 y. And then I have 1 z. How many z's do I need? I need 2 more z's. That's right, but I want 3. So if I only have 1 and I want 3, what do I have to do? No. If I go to the grocery store and I put 1 apple in my cart, and my mom says, no, you need 3 apples. How many more apples do I have to go and get?
Wait, what was it?
I took an apple. I need 2 more. Well, that's the same thing here. I have 1 z, but I need 3 z's. How many more z's do I need? 2 z's. Yes. Okay. Now, remember, what I want to do is I want to multiply by the equivalent of 1. So whatever I write in the denominator, I'm also going to write in the numerator. Whatever it is, anything that I write down here in the denominator, gets written in the numerator as well. Yes, ma'am?
If you're squaring the denominator, would you want 2 of each thing?
That's right.
Okay.
Or multiples of 2.
Right. And same thing if you're scoring it, you want
Yes, if you're foring it. Very good technical math there.
What did you just say? Foring?
Foring.
Oh my god.
Yes, here in the math world, we say foring. Okay, does anybody have any questions about what we did or why we did it?
What's the purpose of it?
I explained what the purpose was.
I'm sorry. What, is that the final answer?
No.
Oh, okay. Just making sure.
Okay, now the next step is to multiply. Okay, so you go to whatever's in the numerator, you multiply together. So I have 5 times 2 times 9. So 5 times 2 times 9 gives me 90. And then I have x's here and y's here and z's here. So I don't have to do anything. So there is my 5 times 2 times 9. And then these are the variables that I multiplied together in the numerator.
Wait, where did the x come from? Oh, it just came from.
Now, as for the denominator, what was I trying to get? Groups of what?
3.
Groups of 3. So that's what this looks like, groups of 3. When I multiply the 2 radicals next to each other, this is what I get in my denominator.
This is where it all translates.
Exactly. want. That's what it means to rationalize. We're going from irrational values in our denominator to rational values in our denominator. The next step is to simplify. Now there's nothing to be done in the numerator. But if I take the cube root of this, I get 2. If I take the cube root of 3, I get 3, and so on and so on. And look what's happened. I've now gotten rid of my radical sign, and all I have left are some rational values. Now, this last step is not always going to be necessary. In this case, my last step is to simply combine 2 times 3, and it gives me 6. And then I am finished. Notice I don't try to simplify this any further. I cannot simplify by dividing the cube root of some value by just some number. If I can't do the cube root of 90 divided by 6, the answer is not the cube root of 15. Okay? So that is not simplification. Multiplying 2 times 3, that's simplification. The cube root of 90 divided by 6 can't do that. Because the has to be the same index. Questions? By what?
Like after step 3, I got the multiply the numerator.
You understood the multiplication.
No, because I didn't get step 3.
Okay. See how the index is 3? In order for me to get rid of this radical sign, I have to have perfect cubes in my denominator. Okay? So what I'm going to do is I'm going to multiply the denominator by whatever it takes for me to get a perfect cube. So I already have 2 to the 2nd power. What's 2 cubed? 2 cubed is 8. So what I really want is 8 over here. Right? So I have 2 to the 2nd power, which is 4. What do I multiply 4 by to get 8? 4 times what is 8? 2. So that's why I put a 2 here. It's easier to do it in terms of the exponent because this tells me I already have 2 2's and I need 3 2's.
Oh, okay.
I have how many 3's here? 1. If I want, this is like the apples at the supermarket. If I need 3 apples and I have 1 apple, how many apples do I need? 2 more.
The text.
If I have 2 y's, Laura,
I'm listening.
how many more y's do I need to get 3? 1 more. And then if I have 1 z, how many more z's do I need? I need 2 more z's.
Wait, but it's already. Why do you need 2 more zeros?
Because I want 3.
But there's already square.
What?
Well, if you do 3 times, in the first parentheses, 3, there's only 1 z. So isn't that 6 z's now?
No. Because when we multiply exponents, we add the exponents together.
So that would be 5?
Forget this. Only focus on the denominator.
No, I am.
Okay, so how many z's are here?
1.
How many z's do I need? I need
But you
3.
already have 3.
I don't have it 3, I only have 1.
But what about the 3 right there?
This?
No, other one.
That?
No, at the exponent 3.
There is no
I
3.
don't know math. The 3.
There is no, the only 3 is here.
No, the cube sign. The cube sign. There we
This.
go. Yes.
That's telling me how many I need to make perfect. If this was nothing, then it would be perfect squares. If it was a 4, then it would be the fourth root. I would need groups of 4. This number tells me what all of these have to be before I can rationalize the denominator. So since it says 3, I need groups of 3. If it said 2, I need groups of 2. If it said 7, I need groups of 7.
I just don't understand why you put a 2 there, because doesn't it add up to 5?
Wait, this is how many z's? You don't start with 3. You start with however many you have here. How many z's do you see here? I'm pointing to 1. How many do I need? 3. I have 1. I need 3. How many do I have to add? 2.
But what about the y?
Well, I had 2 y's, so I only have to add 1. You're making it more complicated than it is.
I know I am, but it's just really confusing.
Does anybody have any other questions? Is there anybody not done copying? Okay. So again we're dealing with cube roots. So again we want groups of 3. How many 5s do I have? 1. How many 5s do I need to add? 2. I need 2 more 5s. How many y's do I need to add? I need 1 more y. Whatever I multiply the denominator by, I multiply the numerator by. My next step is to multiply. 5 squared times 7, otherwise known as 25 times 7, 175. I only have an x here, I have nothing to multiply it with. I only have a y here, I have nothing to multiply it with. What happens in my denominator? I get 5 to the first times 5 to the second gives me 5 to the third. I have y to the second times y to the first gives me y to the third. I can't do anything here. If I can simplify this, I do, but I can't, so I just rewrite it. The cube root of 5 to the third power is 5. The cube root of y to the third power is y. Okay, does anybody have any questions?
Yeah, but I'm not going to talk.
Okay. Any other questions?